This is an example of a fourth root. Notice the 4 over here. So what we're looking for is 4 factors that are exactly the same under the radical, and if we find them, then we'll take 4 out and we'll have 1 in front. So in this case, 32, that's really 2 times 2 times 2 times 2 times 2, and x to the 8th. That's a lot of x's. I don't know if I really have the energy to write all of them, but I can write this. I'll write x to the 4th times x to the 4th. And then y, kind of the same thing. I'll write y to the 4th times y to the 4th. That gets me 8, and then y to the 3rd. So why did I write out the x to the 4th and the y to the 4th? Well, what my hope was is that if I have x to the 4th and I take the 4th root of it, I get an x. So I wanted to see how many x to the 4ths I could get out of x to the 8th, and how many y to the 4ths I could get out of y to the 11th. So, and the same thing with the 2's. With the 2's, I can see that I have 4 2's, so that's 2 to the 4th. So one of those, these 4 2's come outside the radical, this 2 stays inside. So let's go ahead and write that out. So out inside in front of the radical, I'll have a 2. And then I'm going to have 1x, because the 4th root of x to the 4th is x. And I'm going to have another x, because the 4th root of x to the 4th is also x. And then I've got times y, and then I'm stuck. Now I have this guy that's left inside the radical and this guy. So I'll go ahead and write that out. The radical remains a 4th root. It doesn't magically change to something else. And we're stuck with a 2y cubed underneath. Now, normally, if I had an even power and it becomes an odd power, then I would put absolute value signs. But that's not really what happened here. We started with an x to the 8th, which was even, but we really ended up with x squared, which is also even. So there's no reason to put absolute value signs. And the same with the y squared. So we end up with this. The 2x squared times y squared times the 4th root of 2y cubed. And that is our final answer. So that's how we simplify a 4th root. And we would apply the same process if we had a 5th root or a 6th root or a 7th root or whatever. And speaking of absolute values, let's have an example that has some more absolute values so you can see that again. 64 is the 6th power of 2. So what we've got here effectively is the 6th root of 2 to the 6th. And then we've got x to the 6th. Y to the 7th, we're going to look to see if we can dig a y to the 6th out of there. And we can, because y to the 6th times y equals y to the 7th. Now, because of that, that means that we can go ahead and start taking things out. The 6th root of 2 to the 6th is simply 2. The 6th root of x to the 6th is x. And the 6th root of y to the 6th is y. Now we're stuck with a y on the inside, and we're still dealing with the 6th root of whatever it is. And so we'll go ahead and put that y in there. Now, some of you might be saying, whoa, 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 dude, you forgot the absolute value signs, and you're absolutely right. We start out with an even power, we end up with an odd power, so we got to go ahead and put absolute value. Now, the same is true for the y to the 6th, so I'm just going to put the absolute value signs around both. I could have just done absolute value of x and absolute value of y. This is exactly the same thing. So, there you have it. Now you've got one more example with absolute values and another example of an nth root. Here's a 4th root, here's a 6th root. And so that should be good.